Hello and welcome to CS264. This is Lecture 6 and this is Lesson 2. This lesson deals with OOP encapsulation using C#. So we're going to examine encapsulation, which is a fundamental concept in object-oriented programming, and it refers to the bundling of data members, that's like data attributes, and related member functions, that's the methods, that work on those data within a single unit, for example, a class in C#, in C++ or Java. You'll have seen this already in the lectures and also when you develop with Java. I'm just reviewing it here mostly for the sake of completeness, but there might be something that you haven't seen before. So the concept of encapsulation is normally used to hide the internal representation or state of an object from the outside, and that's referred to as information hiding. The general principle here is that if you have an attribute that's not visible or public outside of the object, and you bundle it with methods to provide read or write access to the attribute, then you can hide specific details about the attribute structure. And you can also control access to the internal state of the object. So in essence, you're providing this controlled interface to the outside world, and that outside world are the users of the object, and it could be another object, of course. So normally, you've seen this with Java, okay, and also you've seen it in this lecture series, and you implement information hiding by making your class or the assembly members inaccessible. So you make them private, for example, from the outside, and providing public getter or setter. Sometimes you see these referred to as accessor and mutator methods for the attributes that can be readable and updatable by other classes. So the following section then gives you a list of all the modifiers that you have for C#. I'm sure you've seen these before. We sometimes refer to this as access control. So the first step, typically anyway, in encapsulating an object state is to determine what type of access that outside users or outside clients should have to the class members. As this table here summarizes the access. So we have the access modifier and a brief description. So we have private, protected, internal, and public. Yeah, with private, only members within the same type of object can access it. In terms of public, any code can access it or anyone can access it. Protected, only derived types are members of the same type. Okay, and internal, code within the same assembly. That's code external but in the assembly. And protected internal is code from the derived type or code in the same assembly. So we typically, and I typically use private, protected, and public, and they seem good enough for me, or they seem okay for me. I guess the internal and the protected internal relate to assemblies for when you're probably producing, packages for distribution, and also you want to roll these into some executable, for example. Okay. So the next step then you have to decide is, from two available approaches, how are you going to realize encapsulation and manipulate the private data members? Okay. The first method is to use a pair, and I'm specifically talking about C# here. The first method is to use a pair of conventional accessor and mutator methods. And the second method is using a named property in C#. Either approach is fine as long as you set the access control modifiers appropriately. You'll see me using properties quite a lot because I quite like them, and also if I'm using C#, they're in C#, so it's nice to use the C# features. I mean, when I'm using Java, I tend to use accessor and mutator objects. Methods myself associated with objects, but let's have a look at these ones in C#. Here's a simple example. Does not use encapsulation first. Okay, the data members are all public and are accessible from the outside. So my encapsulation. It's the program. So here we have members, length and width. So what is this? It's a rectangle. So we're trying to get the area of a rectangle. We're going to show the rectangle, and then we have a main program that uses this rectangle by creating rectangular objects, or one setting the length, the width, showing the details, computing the area, and read line. So there's no, so what's happening here, I guess, is that we can access the details from outside of the object, I guess, itself. So it's a fairly straightforward one. So here's a version, my encapsulation again. Okay, they're all my encapsulation. So here's probably a better one because it uses getters and setters. Okay, so here we're privately hiding the data members, the length and width of the rectangle. And we're using methods then to set the length, set the width, and to get the area. Okay, so we can yeah, that's not too bad. Okay, so here we have an encapsulated rectangle. That's the end of that class. And I guess what's happening, if you look at the demo code I give you, they're all called my encapsulation, but here I have an encapsulated rectangle and I have a public rectangle, and these will be in the same file. So you'll see all of those. We'll have a look at that in a minute. Okay, I guess what's happening here is that we can't access the length and width because they're private. We have to actually use these methods to get them. Okay, and we're not dealing or looking at, or I haven't provided these accessors. We're just the mutators here. So let's maybe just have a quick look at that. Okay, before we do anything else, let's. Okay, and it was called my encapsulation there. Okay, so that's fine. So let's have a look at this. Okay, so this is the program, and I guess it has a class rectangle, which is we've seen already, and this is the public rectangle, and then we have an encapsulated rectangle which has private headers, and there's another one. There's properties one, which we'll see in a minute, and that uses properties. And this is the first part as it runs, as I've shown in the example. This is the second part that deals with encapsulated rectangles, and this is an encapsulation using properties. Okay, so this one here uses the accessor and mutator methods, and then this just allows us to be able to access the length and width from outside of the class. Okay, so we don't have to be doing this kind of thing because it's public, private, and the public stuff again here. Okay, but so let's see how it works. And it all works fine, you know, it does, but again, it's a different way to do all of this. So let's go back to the code. Okay. There's this properties approach. As I mentioned, C# also provides properties that protect data members inside the class by specifying the mutators using set and accessors using get. And the earlier approach to encapsulation is good, but I think the properties one is better because it's more streamlined and clearer. Okay, so you can here set up your properties rectangle. So here we have private double length and private double width, and they're creating this is lowercase l's, and we're having a public double width and length, and you can see the accessor and the mutator methods here. So you can remove this to make it set only if you want, and remove this one to make it set only if you want. We can calculate the area. In fact, we can have methods, property methods as well if we want. I might see that in a few lessons later on. Okay, and then this is just a show which writes the information. It's the same as the other ones, and that's it. Okay, so this is a nice way of dealing with encapsulation within C# that you might not see elsewhere. Okay, so short lesson. In summary, we've learned about encapsulation using C#. We learned about the approach. The reason, of course, is data hiding. And I know we're dealing with very simple structures here, like single variables, but you could have complex data structures that you want to hide from the user as well, of course. It's worth saying accessing the data members using a mutator is better than accessing them directly, as a mutator may implement some data validation and so forth in turning the class. That's preferable to leaving it to the using code. So if we go back up and look at the very first one that we had, we were setting a value here, or one that length. So but we specifically said it was a double here. But what happens if we try to make it something else, like a string or something like this? Then your program would throw an error. Okay. Whereas if we have these kinds of properties approach, or in fact if we have some of these approaches, then we can do something a little bit more interesting as well. We could do all sorts of checks and error checks, maybe bounds on the variables and so forth, and handle those errors nicely, which wouldn't happen if we were just dealing with accessing the properties, the member properties directly. Okay, we leave it there. Thank you very much for watching.